你眼睛诶，
Hello, hello. Okay, good afternoon to everyone. I think I received a good email from you guys, messages asking about assignment. I think it's a quite a positive attitude, so please keep it up. And also, I heard that you guys need extension. Is it all of you? Is it all of you? Yeah. So what's the first deadline? When's the first deadline? This Friday. Okay. So we extend to which day again? Monday. Okay. So I give you one more weekend to do it. Is that okay? So basically, what we have done so far is enough for you to do question 1 and 2 already. Okay. Hopefully by today, latest by tomorrow, you should be able to learn all the tools that you need for question 3. Does it make sense? Okay. Some of you are worried about the difficulty, difficulty of the assessment. Okay. So typically, assignment will be harder than your homework question, like the tutorial question, and also your test. Okay, because assignment you are given more time to do. Okay. And about how much proving you need to learn. Okay, this is a very good question actually. Okay, so we need to be able to hold this standard. So how much proving you need to learn? Basically, whatever I taught in this class. So on the board, okay, I discussed with you. Those proof you have to be able to produce. Does it make sense? Okay, now. So that's why in class you don't understand what I say. Make sure you ask. Okay, so you need to make sure you make sense of what I teach you every time. Okay, otherwise you go back and learn, you still don't understand. Okay, so make sure you ask in class. So I won't worry. I won't worry about people not coming to my class because my class is customized for each class. Even I teach maybe this is the third time I teach computers 2 already. Maybe I put different emphasis in each class. Okay, so I tailor this course for you. Okay? So there will be different emphasis here. Why this would happen？为什么？为什么每年教一样的，但是可以考不一样？不是说完全不一样啊，但是重点为什么？Because there's so much thing to learn. Okay, we only have like 5 hours to mix each week, so we need to put emphasis on different things. Does it make sense? Okay, okay. So whatever you see in class, okay, I talk from my mouth one. You don't understand? Make sure you ask me. And make sure you ask. And or you can go to this Math Help Center. Okay, this by the master student because they have scholarship from the uni. They have to work for uni. Okay, so they provide help for calculus and linear algebra mostly. And also come to my office hour. Later I have office hour. Right. Yesterday I also have office hour. Yesterday your class got one student came. Okay. Hopefully, if you don't know how to do assignment, please come to get help. Okay. Later we have 3 to 5. Okay, there will be senior around also if I'm not around. Okay, they all these seniors are taken my course before. Okay, so they know my pattern, they know what I want. Does that make sense? So you can ask them, okay, how they study, how to do study, these courses. Okay, does it make sense? Okay, now. Anything you worry about this course? Want to ask? I hope you can 专心学习啊，不要被这种外在的东西影响。你只要努力读就对了。OK，I will reward you，就天会赏赐给你的，你只要努力就可以了。OK 了吗？如果不明白很难问来问就对了。OK，I know this is very hard. You know why 啊？This calculus how long ago? How long ago? 100, 400, 500. Before that, people already start thinking about it, 1,000 years ago already, people already start thinking about it. Of course, these are like the 结晶, the result of 1,000 years hard work, 2,000 years hard work. Of course, nothing is easy in this world. Okay, now. So I want you to 认清事实. Okay, see this fact, and then 下定决心 learn. Just learn. OK 好 ，OK，埋怨是没有用的，对，他只会害你吧，他不会害我。OK，I am willing to help. I'm here to help. That's all. OK，OK，Sorry 啊，我今天讲话有点生气啊，有人惹我生气今天。OK，不是你们啊，Anyway， 不要在意啊，不是你们，但是就是。OK， right. So let's start with warm-up question first. Let's do some warm-up question. Okay, let's do some true or false question. Okay, so you expect this kind of question coming up in your exam midterm. So in your throughout your revision, try and think about some statement. Think about whether it's true or false or not. Can you prove if it's true? If it's false, can you prove it is false? Maybe you need to give counter example. If you stuck, really stuck, I think I got a good idea. Come and tell me. Okay, ask me. Okay, or you post on the forum also can ask your friend. Put inside your group chat. Ask your friend. Hey, the group chat seems very quiet. The class chat, maybe sometime you can listen up the group chat. Ask them want to go out eat or not or what. Organize some meeting. Or you ask them, hey, today got class or like what? Remind them. Everyone finish assignment already or not? Something like that. 互相提醒一下. Yeah. Okay. Okay. So right, let's start with this question. So this question actually pulled out by Enzi last time. So if a function diverges, does it follow that if you restrict this function to natural number also diverges? So if you just restrict the natural number point, meaning what? The sequence. Okay, sequence defined by this function diverge or not. Okay, I give you 3 minutes. Think about it and then discuss with your friend. Okay, so you need to recall what is all these words mean. There are only three things maybe. Function diverge and a sequence diverge. And then we use if then to connect them. Another thing about your assignment, how to solve your assignment. Actually, there's no particular way I want to bound you. Like, okay, later I show you. Okay, later I will show you after this. Let's do this first. Okay. What do you think? True or false? False. Okay, so if false, how to prove this is false? Can you tell me what's the strategy first if you want to say this is false? So you need to give a counter example. How to give a counter example to an if-then statement? What do you need to produce? You need to produce an example that satisfies the completion condition, the P, and then not satisfying the necessary condition Q. Okay, so in other words, in this specific case, what do you need to produce? You need to produce a function that diverges, but the sequence converge. Okay, so can you give another example? Okay, so how to define it? F to be what? I 2 pi x. Okay, for all x in R. Then what happens if you look at Fn sine 2 pi n for all n? Okay, first of all, is it diverge or not? So let us check first before we check the second statement. So consider limit n to infinity of fx of limit of sine 2 pi x. Anyone know what's the limit of sine 2 pi x or not? Don't know? Don't know? But can you draw the graph or not? What's the graph looks like? It's a sine graph, right? Okay, it's just a sine graph. Is correct. Okay. What's the period here? Period. Huh? What's the period? So what's the period here? Oh, 1. Okay, 1. Yes. 1, right? Because sine 2 pi is 0. Then when you multiply 0 to 1, the number between 0 to 1 to 2 pi, you get everything between 0 and 2 pi. Okay. Good, very good. This is very important. This will be important when you learn Fourier series later. We will need to deal with this sine function. But you can see that this point like alternate between -1 and 1. Okay, so it diverges. It alternate between -1 and 1 always. So you can use the same argument I told you last time, right? Contradiction. Suppose there's a limit. Okay, and then see can you get arbitrarily close to that limit or not. But your point is always alternate between -1 and 1. Okay, you can always find some point further from the limit that you suppose. Okay, so doesn't exist. Okay, or diverge. Okay, so now we want to argue what this sequence here. Okay, maybe we don't put Fn. Okay, just put Fn, but to be more familiar to you, maybe we define this An to be this. Okay, to assure you this is really a sequence. Okay, but this sequence here, what is this sequence here? If I set this sequence here. It's sine 2 pi n. What value you take? What's sine 2 pi, for example? Sine 2 pi is what? 0. Sine 4 pi? 0.6 pi? So, this what sequence is this? Constant 0 sequence. Okay, so this is always 0. Always 0 means what? Converge or not? Conversion. Okay, so then, then this constant 0 sequence converges to 0. Okay, not only converge, we know the limit, which is 0. Okay, no? So limit and 0, limit and convergent is what we define, right? If you have a limit, then your function converge to that limit. Okay, so they are the same. Converge is a verb, 一个动作。Okay, limit is a nouns. Okay, if you converge, you must converge to something. And have a limit is also means converging. Okay or not? Okay. Right. This is what we defined last time. Okay, no why, because we defined it. Let's check the definition. Okay. So far, okay? Okay. Okay. So next, I want to come back discuss about this first before we talk about how to answer assignment question. Let's talk about this. Equivalence definition of sequence. Okay, this week we go up a level a bit. So today is the second week, right? So let's remind ourselves, what is the definition of the sequences? A sequence is what? A list of number. This is just a list of number or not? What else you need? In order. Okay, you need to be in order. Remember, why is it in order? How do you list down the sequence? Typically, you list down as A1, A2, A3, A4, A5, like this. Okay, so these are real numbers, and then they are in order. We put 1, 2, 3, 4, 5. I cannot put like 2, 3, 100 like that, right? I cannot do this. And not sequence. Okay, so we need to do in order. Okay, we need to do in order. Unless this is a new order, that's a different story. But they have to be in order. Okay, they have to be in order. Okay. If you do like this, maybe your new sequence, you can name it as like this. B1, B2, B3, like that. Okay, new order. Okay. Otherwise, you cannot simply place your order. Does it make sense? Okay. Okay, so in order. But you also hear me saying, a sequence is a function. Okay, function from N to R. You already actually see me using it already. Okay, but why are these equivalent? Can you prove or not? Why is it equivalence? Okay. The first thing in mathematics is to prove equivalence of definition. Okay. We can give a lot of equivalent definition for one thing. But are they really the same or not? This requires proof. Okay. So let's name this definition. So here is definition 1. Here is definition 2. And let's prove that definition 1 of our claim is def1 if and only if def2. And so meaning, if you give me sequence of, give me a list of number here, then I can give you a function. If you give me a function, I can give you a list of number here. So when we show this equivalence of definition, sequence here is not important already. 我已经不知道什么是 sequence 了。What I know is this list of number in definite order or the function. Remember the banana game or not? Banana game. You can forget what is banana. You just need to remember what is a red, round, straight fruit. Okay. So obviously, these two things here is different, right? Can you recognize that they are different? So list of number in definite order. One is function. One is function. One is a list of number. Obviously different. Around. One is function. One is set of things. Different, huh? Different object. So why are they the same? Why are they equivalent? Why can I simply go between these two definitions? Okay, so this requires proof. So let's prove it. So let's prove one direction first. So def1 to def2. Okay. So this means what? Suppose what? Suppose A1, A2, A3, so on is a list of number in definite order. Okay. What do I want to show? What do I need to show? Okay, the important thing about proof writing, the way I teach proof or I write proof, I will write my end goal first. What do I want to show? What I want to achieve. I will keep reminding myself. Otherwise, inside a long proof, you will forget. Okay, so write down what you want first. What I want to show? I want to show that. Show what? A1, A2, A3. This AN here, or simply AN. Okay, let's call it AN. AN defines a function. Does it make sense? Okay, give you a list, you produce a function. Okay. Do you have any idea or not? If I give you this list, how to produce a function. Do you know how to produce function? How to define a function? How to define a function? To talk about function, you need to tell me where all the things in the domain go. What are the things inside your domain of this function? Recognize which one is domain. Natural number, right? So you need to tell me where all the natural number go. What do you think? What kind of induction? You need to tell me where they go first, right? One have to go where? A1, no? Isn't it? Two, leh? A2, no? Three, leh? So on, no? Right. So this means what? You are defining this function defined by f takes n to an. So, okay. 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 Any question? No? Clear? Okay. How about the other direction? If I already tell you how all these 1, 2, 3, 4, 5 go, okay. How do I define an? How about the other direction? If I already tell you, I give you this one first, the ballet mark, right? Do the other way. I give you this function first. I already tell you one go where, two go where, three go where, four go where. How should I define an? How should I define an? How should I define an? What is A1 then? Any idea? Yeah. So we simply define AI or AN to be Fn, the image of n under F. Make sense or not? Okay. So these are the language that you need to learn. Okay, you need to learn image of the function. Okay, because I know where is F1, Fn already, right? So I simply name them, give them a new name, AN. And this define a sequence. Correct. This define a list of number in definite order. Correct or not? Okay. Why you always get order for free here? Because actually you are using the fact that natural number is ordered. Okay, so there's something come for free. Does it make sense? Okay. So in other words, what this equivalent definition tells you what? Sequence is just image of some function. Okay, from n to 1. Question? Question? Please ask. If you have any question, stupid question also can. Don't understand notation also can. Because notation is very important. So part of the reason why pure maths is notoriously hard is because of language. We need to learn new language. We learn new language. New language is hard. Is it hard? 你叫什么名啊？小鹏啊，从哪里来？中国哪里？河南，说方言吗？说说看，河南话呢？说一句来看啊，一句，中，一句哦，中是一个字还是一句话？说不上来，哎呦，要失传了。那努力学。那比如说，我跟你说我是福州人，我跟你说下班没？听得懂吗？你听得懂？你听不懂是不是？是不是？哎，后面人听得懂哦。可是你是福建人，不是？有点一样啊。但是就是说，what I want to tell you is new language is hard. Maybe sound completely different, but you are here to learn it. Okay, you need to learn it. Okay, so from my class, my student, I don't train them to do maths only. I train them to speak maths. 懂什么意思吗？你可以沟通，用数学，不是做法，不是算法，不是纸上谈兵嘛，是可以活用出来，在生活中活用出来，在生活中跟人家，不是吵架，英文是 argue，辩论 argue，OK，明白吗？好，try and learn throughout these courses, throughout this course. Okay, good. Next, next I want to talk about your assignment. A lot of you, I mean, this is normal because this is how we train since our high school or our primary school in education. Not only in China, in Malaysia, I think in Asia, most probably. We are trained to do question in one way or few fixed way. Okay, because you know why? You know why? Actually, have you think about this? What? Get high marks, okay? Get high marks, not really. What else? 那个是老师分。还有吗 ？Yeah, easier to mark. 比如说你们高考几百个人或者几千个人，还是几万几十万哦！如果几十万个不同的答案，你想想看，你怎样改？是不是？所以为了容易改哦，全部人跟我写一样的就对了。你明白吗 ？OK。But anyway，那个都是旧故事了，那都是旧故事了，大家都已经读上来了，对不对？所以我们在大学已经是不一样的教育了。OK，我们要develop。We need to develop a growth mindset. 为什么要 growth mindset versus fixed mindset? What we want to do here is develop growth mindset. 用你的思维，用你的思考，能不能走出一条路来？这才是我们要，这才是 research 要的。For example, okay. So for assignment, 再走回来 let's come back. So for assignment, right? If you think that you have another way to do that's not related to my kin, you can use it, but based on what principle? Okay, this is very important. Based on what principle? If you don't want to use my note, but you need to at least use the tool I use. Make sense or not? Use the object that I define. Maybe you have different way to get it. 而不是去用一个可能其他理论的东西进来。Does it make sense? You need to use whatever I define. For example, if we learn sequence, okay, use sequence. If we learn series, use series. Okay, it's not good that you use maybe very advanced or that we never done before to solve it. It's possible, but this is forbidden because you need to understand what I mean. You need to understand why this course exists. 最基本的问题 is for you to learn these basic stuff. So whatever I said for you, you should be able to use this basic stuff to solve it. Okay or not? Does it make sense? Okay. Okay,明白. Okay. So whatever you do, make sure it makes sense. For example, just now, Jianhong asked me, can I use the result? Maybe a sequence is bound by the other sequence, but the larger sequence has diverged to negative infinity. Does it imply an diverged to negative infinity? You need to prove it because I never proved it in class. You cannot just use it. Okay. So if you want to use something that I never proved before, then you need to prove it. Okay. In class, a lot of things I didn't prove already. So that one is for free. FOC. You use them? I didn't ask you to prove. Either I prove it or I waive the proof. No need to prove. Use it. Okay. Understand? Is it clear on what you need to use in the assignment? Is it clear? Okay. Okay. So if you want to not using the standard way, then you need to argue why you can do this. Okay. Any question? Maybe you will still make question like when you try to do assignment, but just come back to me again. Okay, ask me whether can use or not if you are not too sure. So why I give you hint in the assignment? You know why? You know why? What's the reason that people give hint? Because easier, huh? For you to be easy. Huh? What is for me to be easy? Both way. So the reason I gave you hint is because maybe, okay, maybe there are a lot of ways to solve it. Okay, maybe you will like get confused. So I just point you one way that you can go and I tell you this way you can work it out. So you just focus on working this way. If you turns out, hey, I know another way. Okay, never mind. You go ahead. Okay, does it make sense? Okay, 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 okay. Okay, so let's come back very concrete example. Concrete example. For example, last time, there's one thing we proved, right? We proved that two sequences are equal. Okay, we proved two sequences are equal. So remember that in class we also proved that two sequences are equal. Okay, but when I prove it, what's the technique I use? I use mathematical induction, right? But is it possible to prove without mathematical induction? Is it possible or not? If I still want to show for all n, infinite n, can I still do it without mathematical induction? What's the reason we use mathematical induction? First reason is we want to show infinite things. And then the next result should be based on the inductive hypothesis. So you need to base on the truth of previous case. But can we prove this statement without mathematical induction or not? No one there to answer. They can. But how? So meaning we need to show an equals to bn for every single n. For every single n. Is it possible to do so or not? Do I really check everyone? Crazy man. Can I, without checking explicitly one by one, but I still can show for all? Cannot. Okay, how do I do it? Okay. So first thing is B1 is very clear here. B1 equals to 1. Can we first check that? Can we first check that or not? Okay, if we first check that, what happened? What is A1? Okay, wait, sleep there. Huh? 1, right? Okay. But A1 is just equals to B1. Good. Very good. How about the rest? How to show? How to show the rest? So the rest of the Bn defined on Bn minus 1 for all n greater than equal to 2. So if I can show that An satisfies this property for all n greater than equal to 2, then I'm also done. Okay, but is it true or not? Is it true? For n greater than equal to 2, what is An? What is An? Definition of An. Okay. definition of AN. Definition 这边 definition. When I ask about definition, I look for this kind of dot equal. What is the definition of AN? 3n minus 2. Okay. What is AN minus 1? 3 times n minus 1 minus 2, which is what? 3n minus 5. Okay. But what is AN minus 1 plus 3? What is this? Everyone see? What is 3n minus 5 plus 3? Wait, before AN, don't jump first. 3n minus 2, which is AN. So you see, for all n whether equal to 2, AN also satisfy the same D. So they are the same. Is there any difference if I name this with Cn or not? Cn, C1, Cn, Dn minus Cn minus 1. Any different? Or if I name it Dn, D1, Dn equals to D minus 1. Any difference or not? No difference. Because what is important is the relation between n term and n minus 1 term. So AN also have the same relation between n term and n minus 1. Okay, no? So they define the same sequence. Does it make sense? Okay. Seems this agree with the definition of Bn. For n greater than 2 and n equals to 1, AN equals to Bn for all n. Okay, does it make sense? Okay, okay. So you can think of your Fibonacci thing can be proved in this way also. Okay. So if you want to use, if you need to use induction, then you use induction. If you don't need to use induction, then you can ignore. Okay, depend on how you write the argument. Does it make sense? Okay. Okay. So in this course, sometimes for one question, I give you multiple ways because I want to let you to see you can do it differently. Because differently, you will see different phases of these truth or this statement or this theorem. Does it make sense? Different way to express, different way of seeing things. Okay, because if you just see things only one way, it's quite hard for you to learn. 因为我做的数学是从很多面向进来，有几何啊、代数啊、分析啊，全部在一起的。OK， 所以我们要从不同的面向看数学。Does it make sense？ 对吗？你也有不同面向啊，是不是？你不是你妈妈的儿子吗？不是你公公的孙子吗？你不是你的同学的朋友吗？对，每个人都有不同面向的，从不同面向你就不一样了。在家可能你就很放肆啊，在我的班可能你就静静。但是都是你啊，难道不是你吗？你多重人格啊，多重人格也是你啊。OK， 呀，诶，这个班没有不会听华语的，不是？真喜欢搞笑你们两位。Yeah, anyway, so maybe 有些东西我不用 translate 去英文，有些帮助下。OK， 哇哦，今天我们拿40分钟来做这个。Okay, let's continue first. Okay, let's continue and then we'll take a break. Okay, let's come to a new stuff. So today we'll prove this theorem if lim of modulus of an is 0, then you can tell us about the limit of the original sequence. Okay, so what this means, this means that this limit of the modulus sequence is quite strong. Okay, you know that this modulus an converge to 0, the original one have to converge. Can you quickly imagine what this sentence want to say? 你看到数学字最好要有画面感。如果你只看到英文字或者符号，就没有什么意义。你要有画面感。什么画面感呢？Whenever we talk about sequence, how should you think about sequence? Maybe it jumps around real number. Okay, in an order, right? So you need to space out them. 有间隔的。But modulus means what? 全部 all the negative value you push to the positive side. So if you push the positive side and then you try to make the limit go to 0, that meaning what? The original one also have to converge to 0. 可以想象我在讲什么吗？ Okay, so let me draw for you. So let's say you have a random sequence. So schematically, how about the sequence randomly jump like this? Okay, if I make all of them positive, make all of them positive, and the positive one converge to 0, then the original one also have to converge to 0. Does it make sense? Okay, ma. So every time I write down this mathematical statement, I make sure you know what image to form inside your mind. If you just look at 这么多字我也记不了其实。这边有几个字1、2、3、4、5、6、7、8、9、10、11、12、13、14、15、16、17、18、19、20、21、22、23、24、25、26、27、28、29，这9个单字，这个是一个图吧？你不要笑你不要笑因为有真的学生他就是一字不漏的抄进考场里面，他不知道怎么用的，真的，你不要笑，真的，抄一模一样，字不可以变的order 不可以变then 的这个不可以变的，一字不漏抄进去，考试还是不会做，因为他没有这个图印在他脑里面，他不知道这个句子在干嘛，明白吗？ Okay, so make sure you can understand the mathematical statement and make them into something that makes sense. Okay, something that makes sense to me is geometry picture. Okay, drawing. Okay, so how do we prove this? Okay, I let you think a bit. Okay, how can we prove this? You based on what we learned last time. How many tools we learned last time to find a limit? I think there are 3 of them. First is what? If you know the limit of the function converge, then you will know that the sequence defined by the limit also converge. Second, properties of convergent sequence, right? Limit of k, limit of k times a convergent sequence, limit of sum of a convergent sequence, or product of a convergent sequence, or quotient of a convergent sequence. Correct or not? What else? Squeeze theorem, very good. Squeeze theorem. So there are only 3 tools here. Okay, mathematics like this. Once I teach this, the next one need to use what we learned before. So try with this 3 tools here. Can you prove this statement? I give you 3 minutes time. Discuss with your friend beside you. tried something. You have idea? Sorry, squeeze. How to squeeze? Squeeze what? An less than equal to absolute value of an greater or equal to 2 negative of an negative. That's the inequality here. Everyone agree? 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 If don't agree, then this means you don't know something about this modulus yet. You know how to define modulus or not? Modulus means what? X if what? X is greater than 0, negative x if x is less than or equal to 0. So if you take modulus x, you will always get positive x. Because if it's negative, you put a negative extra on it. So if you have negative 1 here, what's the modulus of negative 1? You get negative 1, which is 1. Okay, 1 is obviously greater or equal to negative 1. Okay, so similarly, you can argue for the other side. Make sense? Okay. So how do we use this inequality? How do we use this? Squeeze, right? So meaning they have to converge to the same limit. Okay. So we know that lim of modulus an is 0. Can we compute lim of negative modulus an or not? How? This is equal to what? Right? Minus lim of negative n to infinity of an. Why can we do this? Right? Because we know that modulus an converge. So I can pull the limit out. So this is by what? By property of convergent sequence. Okay. So in the end, what do you get? This get minus 1 times 0, which is 0. Okay. So you have the an squeezed in between two sequences that converge to 0. So by squeeze theorem, what happened? An also converge to 0. Okay, for n. Did I introduce this notation? Did I introduce this piece of notation? I think I didn't. Maybe I'll add it in. Okay, you can use this as the limit notation. Yeah, so meaning this thing here is this is equivalent. How to say? So equivalent to limit of n to infinity of n. Okay. So wait, you see, so many sentences. Can we do this in picture again or not? Can we do this in picture? Can we do this in picture or not? So this green line here is the modulus an. And you also can make a line for negative modulus an. Okay. So this is really Swiss theorem, right? Is this the picture like the Swiss theorem or not? Okay. Yeah. So I mean, you can use this picture to describe to somebody else's proof, but for record, you need to write this proof properly. And so two things you need to learn are usually in my class. You need to learn idea first. Second, you need to know how to express your idea properly. And this is also very important interpersonal skill for you guys. You got idea, 我讲不出啊，我讲不出。我要这个，我讲不出，讲不清楚，人家不懂我在讲。So you need to learn how to speak this class. Yeah. Then you need to learn how to express your idea properly. At the same time, you will learn how to listen to others' idea also. Listen to what they want to say. Then you need to have an assumption on people might not express themselves well. So you need to try and guess what is actually in their mind. Okay, we can discuss this again next time. But what time is it now? 1:55. Okay, let's do one more exercise and then we take a break. So I teach this proposition, right? So make sure we know how to use this. So let's do example. Let's do this example. Can you quickly think how to utilize this proposition or not? Think very similar example. You want to try? What can I do? Like, what's the first thing I do? Answer. Oh, you mean since we have -1 is less than or equal to -1 for n, less than or equal to 1 for all n, greater than or equal to 1, then so you can divide every term by square root n, is it? Okay, so divide every term by square root n, and then and what? Huh? Who converge? Who converge? 1 over, then how is square root? Since the limit of n to infinity of 1 over square root n is 0, we also have what? Minus the limit of -1 over square root n is also 0 by using the property of convergent sequence. Okay, and then in the end, by squeeze theorem, we have the original sequence converge to 0. But this is the proof again, correct or not? This is again the proof. But we already proven the statement. Can we just use the statement or not? Can we just use the statement? What's the statement? I remind you. What's the necessary condition here? Sorry, what's the sufficient condition here? You need to check that the modulus of your sequence has limit 0. What's the necessary condition here? The limit of the original is 0. So meaning what? If you want to prove a sequence has a limit 0, what do you need to do? Take the modulus first, and then check that the limit is 0. Hey, by the way, do you know how to differentiate necessary condition and sufficient condition? You know how to differentiate which one is P, which one is Q, which one comes first? If P, then Q. Okay, which one is necessary, which one is sufficient? How to differentiate? Otherwise, you don't know what I'm talking every time. Okay, if P then Q and P implies Q. Which one is necessary? Which one is sufficient? Okay, let's start from necessary. P or Q? Huh? Huh? P. What question I asked afterward? Necessary, huh? Okay, necessary first. So which one is necessary? P or Q? Two choice only. You can only make one choice. Q. Q is necessary. P is sufficient. How to remember? Huh? How to remember? There's storyline. There's a storyline. Mathematics about logic. Need to build story one. Sufficient means what? 简单来说，英文字什么意思？足够。Necessary 呢？必须的，必须，must happen。So sufficient 足够让它发生。Enough for the necessary thing to happen. Why is it necessary? Because if you have sufficient condition, it must necessarily happen. 一定要发生。那它发生需要它吗？Doesn't matter. Okay, no. Doesn't matter. But if you have sufficient condition already, then it must necessarily happen. Okay? Does it make sense or not? So there's in mathematics, I want you to keep in your mind. There's a reason why people pick this terminology one. You need to figure out why. Then you will make sense of it. Mathematics is about making sense. 你一定要觉得有道理，可能不是你的道理，是别人的道理，你就要学好。我们已经学了很多古希腊的道理，其实我们能不能造出一个马来西亚的道理呢？有吗？能吗？能的，有了，所以靠你，靠你，靠你们，靠我们，这样的，明白吗？老师跟你们讲我读了很多书，其实读了很多年书了，跟你讲。But 你没有去 experience 这些 knowledge，他们都是只是纸上谈兵嘛。比如说我们读的这些东西你试一下，你去古希腊游玩一下，去跟当地人讲话一下，或者很多我们的理论可能是美国来、法国来的，去那边生活一下，当地生活一下，喝下他们的水，呼吸一下他们的空气，怎么会想到这种东西出来？你呼一下，喝一下，你就觉得哇，很有道理的哦。你们讲的真的太有道理了，其实真的。马来西亚呢？马来西亚的水难道比人家水苦咩？马来西亚的空气比人家的空气不好咩？怎么没有自己的道理呢？对吧？可以的，但是我们需要去说服人家，这个才是我们的problem。说服不了人家，你有道理可能，但是你说服不了人家，人家不知道怎样把你的道理，你明白吗？要看每个人不要看每个人。说服不了人家，所以我们需要沟通，人类是需要沟通。Does that make sense? Okay. Hey, I haven't tell you how to use this proposition in this example here. So this is method one. So method one basically you repeat the proof. So we want to just use what we have proven. What can we do? We just simply check the limit of modulus of minus 1 to the n of square root n. What is this? What is the limit of this? This is the limit of 1 over square root n. But what can we do? We can link it back to the limit of function. Okay, we know how to do this because it's calculus. So, okay, so this one by theorem before, but by calculus one, we know that this limit is 0. So by proposition above, we know that the original limit minus 1 to the power n square root n is 0. 两行. If you use the proof again, 三行. So we make our life easier when we want to prove because we just use the result. Otherwise, you need to go over the proof again, go over the proof again. In this case, we just need to check one thing, the sufficient condition. Sufficient, then it necessarily happen. Okay, makes sense. So this is why we like proving lah. Otherwise, I change another example you use again, same tree line. Then for this proposition, I just need to check one thing. Okay. Does that make sense? Okay. So how many tools you have now? You have 4 tools. Okay, to find the limit. Yeah, before we break, another thing I want to talk about is this guy here. So this guy here, you can also try and show why this is true. Okay, to be pedantic, but we won't focus on this. But if you're interested, you also need to see why this is true. Okay, it's actually easy to see. Do you know? It's easy to see. How to see? Yiliang. How to see? Good. Yes. So basically, you just break into cases. So n is just a natural number, so they are odd or even. So all of them are in between this range. Okay. Good. Okay, let's take a break until 2:15.嗯。
上个学期老师的课件也找到。这个这个是吗？也完全一样。说 A 是好的。
但是你没有这个条件呢，可能你要变一下，就是你的是哪个地方？它 statement 是什么？它 statement 是什么？ 你是要用什么？你要用哪句话？
是
这个他是说这一个是 finite，然后因为 monotone 分时空，这个就
这个就是 converge，这个就 converge。
对啊，
所以说，
所以
如果它是 diverge 的话，一个也就是
是不是他 prove 的？statement 不是他 prove 的对啊，an diverge，bn diverge，但是怎么个 diverge 法呢？一定要去 negative infinity 啊，还是一定要去 infinity 呢？还是不同的 diverge 法？因为 diverge 比较危险，你知道吗？有几种情况，对不对？所以这个 converge 有一种情况吧，最容易说。
呃，其实我也没有仔细想着去证过的。
对啊，对啊，对啊，
就是
对啊就是我要你去想，
所以我直接就是说，我每一个都比你小，
对
然后你加起来是负无穷。
对，哎，你就要说，所
对，
以
你要证明
其实对要蛮严谨啊，其实
啊，不要
对其实要用 epsilon delta 吧，我想一下，要啊，要用 epsilon delta，所以你要知道什么叫做来 level 去那个地方，你和 w 去 infinity，你知道什么意思吗？an 大于 there exists an n such that an 大于 for 每一个 m there exists an n such that an 大于 m，这个是 infinity，negative infinity 就 negative m 哦。每一个 m 大于零，there exists an n such that，或者 for 每个 m 就好，for 每个 m there exists an n such that an 小于 m，这是去减 infinity 哦，因为每一个 m 你都有一个 n 是小于它的。对，Hello，the cake and then 全鱼，川渝有全鱼，川的，OK，建同，李建同，哦，李建同两人，小鹏，小鹏，金盛，全一个，子莹，子莹，品兄，贵，恩慈，雨后，一线，文凭，清香，清香的，一良，没有把一良解了，魏琪，感恩，一向，雨前，humble，小莹，小杨，一平，一平，OK，小燕，Are you in their team group chat yet? You already in? In, okay. In 咩？ You check is he in or not? Feel like he's not in. So in our class, in total now we have let me see, 21 plus me 22. Is it correct or not? The team 32. Huh? Is he inside our group chat? No, Moodle, this is team group chat. Moodle is another thing. That's okay. Yeah, Moodle. Moodle is where I post the lecture notes stuff, class in the team. Team chat is for informal discussion. If you guys found something cool about Max or about calculus too, you can also share into it. You can share into the group. Yeah, share more. If class rep play badminton, also can share. Your class rep like to play badminton, you can play with him. Okay, let's start. Okay, try these examples. Let you try first. Let's give you 3 minutes to try. So for what value of r, the sequence r to the power n converge. Okay, I give you some hint. Okay, otherwise too many are for you to try. So I'll try some hint, see if you can deduce any result or not. So I'll try some obvious number. Okay, whenever you see these questions, you need to start from obvious thing to try. What is the obvious number to try? What R you can take? One. There's one more easier one, very trivial one. 0. Okay, 1, -1, 2 like that. Okay, try what happened to these cases. See if you can deduce anything for all R. Okay. Do you know for what R converge? The idea? Or how many possibility do you know? Or what kind of possibility you get? Well, let's try it down. Okay. If you try some of these numbers, you should somehow get some of the possibility, right? What possibility you get? The obvious one. Obvious one. Which one? Obvious one. 0. Good. 0. Okay, 0. What else do you get? 1. Good. When is it 1 you get 1? You sure? -1, what do you get? What happened in -1? Alternating, right? What did we say about that sequence last time? Average. Good. Okay, so we have one divergent possibility. 1, 1. Anything else? Infinity. Okay. So when is it 0? Just 0? Only 0. And as long as it's in between -1 and 1, right? 0, 1, 0, 0.1 to the power n is what? 0 point n 0, 1. So it gets smaller and smaller. Okay. Infinity then? When is it infinity? Greater than 1. And then when is it diverge? Less than equal to -1. So why I split out these two divergent cases? This kind of diverge is what kind of diverge? The number getting bigger and bigger. But this kind of diversion, also number getting bigger, but how it gets bigger? Jump, right? Up, down, up, down, up, down, up, down, but the gap is getting larger, and larger. We cannot say it diverges to infinity. We also cannot say it diverges to negative infinity. Because it's like last time I told you, right? There are like two limits there. But limit, we only can have one L. We can have two L. Limit is unique if you can prove. Then limit is unique. So I just put a word diverge there. No? So you also can draw this result. So R is a real line, right? So you can record on real line. So where does it converge? It converges all the way from exclusively from -1 to 1. That's all. Okay, so this part is where Rn converges. Okay, other than these places, it diverges. Okay, so we need to prove it. Okay, we need to prove for so many points. Okay, so we need to break down our R to different cases. Okay, so let's prove this. So easily, for R equals 0, we can compute it easily. Okay, R to infinity of 0 is obviously, at the start we already talked about this sequence, right? Constant 0 sequence, which converge to 0. And then, what can we do? We check for other R where it converges to 0. So let's check for the positive guy. Okay, 0 to 1. So does this converge or not? So just now I give you an example, right? 0.1. But in general, how to prove? Have you guys seen this result in calculus 1 or not? Or are you guys using it? No. So basically, you need to use epsilon delta to prove this. And if you like, you need to use epsilon delta to prove this. Once you have this result, what you can deduce? You can deduce for the negative part. Okay, you can deduce for the negative part. How do we deduce it? How we can deduce it? You can use the proposition before. Okay, so the proposition before is good for alternating sequence that converge to 0. Correct or not? Remember just now we use it for -1 to the n over square root n. Okay, this guy is also alternating, right? If you have r to the, negative number to the n, it's also alternating. Okay, so from here, what do we see? We can check the sufficient condition. No? Does this converge to 0 now? If this converges to 0, then the original sequence converges to 0. Okay, but how to compute this? So this is really just n to infinity of n, which is 0. And why? Because you can check that r to the n modulus is modulus r to the n. Okay, and also we have the previous condition. Okay, we have the previous condition. How to write this? Like this. Okay, we can apply the previous condition. Okay, then by proposition before, we know that the modulus converges to 0, so we can deduce that the sequence Rn also converges to 0. Okay, so we are using the previous result here because modulus R is live in between 0 and 1. Live between 0 and 1, we know that this limit is 0. So to prove this, you need calculus 1, but to prove this, you use this result here plus what we have. Question? Any question? Question? Example question or not? You understand? You want to explain? Any question? So maybe if I want to add here is by previous line. Maybe one thing to prove is this one, but this one, if you want to prove this, you want to know why, you can pull the power up. Is it clear or not? To pull this power up. You want to think about it? So for mathematics, you need to convince yourself with example first. Then example will tell you how to prove it. For example, if you want to verify this number, right? How to verify? If I put r as, let's say, -2, okay, -2 to any power, is it true that if I take any power and then taking modulus, is equivalent to taking modulus first and then taking power? True or not? Let's say I try number, you need to try one. Like -2 to the 3, what do you get? -8. But after modulus, you get 8. But here, you modulus first. So you get 2. 2 to the 3, 8. Okay, so you need to prove. Okay. And then once we have this, we can turn it into this. Okay, we can pull the power up. And then how to compute this limit here? We use the previous line here. Why? Because this modulus R is live inside this range already. Right or not? If R is living in -1 to 0, after I take modulus, it will swap to positive side. So I can apply the previous case. Okay, but why previous case is true? You need to prove it. Okay, but we don't do it yet. Okay. Can follow? Okay. Okay, then since we know that the modulus of this Rn converges to 0, then we use the proposition before. The necessary condition is the original Rn also converges to 0. Okay. Yeah. Okay, how about the rest? Let's quickly do it. So for R greater than 0, okay, the limit of Rn is also infinity. Okay, so you need to use your previous knowledge also. To show something is converge to infinity, do you know what you need to show? What does it mean by converging to infinity? What's the definition? 无限大或者无限大 Last time I told you, right, infinity is not real number. So what does it mean? The logical infinity, divergent infinity. Meaning what? Every an for every number m that exists a term inside your an such that an is greater than m. Is it true? True or not? You got 100, there's some an greater than 100. You got 200, there's some other an greater than 200. 1 million, there's some an greater than 1 million. So your an is getting larger, larger, and larger. Okay. Okay. But we won't focus on this. If you want to show, then you need that. Okay. So for r equals to 1, what happened? Limit of 1 to the n is limit of 1, which is just 1. Okay. So this is the only case when this limit is equal to 1. Okay, because you only get constant sequence 1. For r less than or equal to minus 1, this limit doesn't exist because just now we talked about it already. So it get larger and larger, but alternatingly. Okay, it get larger and larger, but alternatingly. So maybe something like this. Yeah. So for these cases, you can try and prove rigorously. Okay, if you want, you can do it in your project. You can do it rigorously. Anything related to epsilon delta, we don't want to do this in this class. Okay, in epsilon delta, we will avoid. Do in your project if you want to ask why. Okay, so this cover every cases because we go from 0 and then -1 to 1 and then something greater than 1, something equal to 1 and then something that's not equal to -1. We cover all the cases already. Okay. Maybe you will ask the question of how do I know how to break to these cases? A very good question. How to break into these cases? Actually, I also don't know. So how? Like what I told you in the hint, try a few number. You see that number in between -1 and 0 has the same way of conversion. Or number between 0 and 1 has the same way of conversion. Number less than or equal to -1 has the same way of conversion. So they group together. You need to try one. Okay, it's not come for free. Okay, just try a few numbers. Make sense? Okay, you try a few numbers, then you will see the pattern. Next example. Example. So this example relevant or not? Okay, this example may be a bit similar to your assignment question. So I want to find this limit here. Okay, how to find this limit? Any idea to find this limit here? Seems a bit crazy here. On the top is a 9 factorial, and the bottom is a n to the power n. So meaning what? Multiply n times. So maybe we can try and expand these things up. Okay, so what's factorial? It's factorial. 1 times 2, or we can start from n, right? N times n minus 1, n minus 2, all the way up to 1. N to the power n quite easy, right? So just n times. Okay. So in calculus, we like to bound stuff. Can you bound this sequence of analysis about bounding actually. So can you bound this sequence? Is there any way to bound them? Do they cancel out actually? Any of them cancel out or not? Can any of these cancel out, simplify? Which one? N over n, right? Okay, so this one can cancel out. The other maybe might not be able to cancel out. But did you see a nice thing or not? Whatever the number appear above, right, it's a bit less than n. So you divide something larger than you means what? This number is bounded above by 1. Right or not? 3 over 4, 5 over 6. Okay. So there's a clever way to bound this. So you can regroup this guy, right? At least, for example. And then all these are less than 1 times 1 times 1 up to 1. Maybe you want to do this. Not very nice. How about we just keep one guy here, 1 over n? Why is it nice? Do you know about 1 over n? What happened to this sequence? Converge to 0. Wow, this guy converged to 0. What does it mean? Can you do some squeeze theorem here? Can or not? How? This sequence is also greater or equal to 0. Is it true? Because our n is always positive. So this is squeezed by a constant sequence 0 and 1 over n that converge to 0. Okay. So since we know that limit of 1 over n, if you want to be precise, so by squeeze theorem, limit of n to infinity of n factorial over n to n is also 0. Okay. Yeah. So this should give some hint to how you to solve your question 3. It's similar. Okay, let's leave it like that first. If you still stuck, then we can talk. Okay, let's go on. So next, we'll discuss about another theorem, another tools, okay, which is about sequence that come from a continuous function of a sequence. What does this mean? So many sequence function. Okay, so what's this theorem talking about? So if, okay, if, so this is the sufficient condition. If you know the limit of the sequence, okay, and you know that a function is continuous. Okay, continuous at where? Continuous at the limit point. Okay, that L there. Then lim n to infinity of fan. Can we do fan or not? An is a sequence of points, right? I can apply f to it. So for every an, I get a image fan. fa1, fa2, fa3, fa4, fa5. Okay, I got a new sequence. You can ask about what's this sequence here? What's the limit here? Does it converge or not? Okay. Actually, it converges to fl. Okay, actually it converges to fl. So you replace the an there by l. But what this means is, this is really what? F apply on the limit of n to infinity of an. So meaning, you see, if your function is continuous at that limit point L, and you have a sequence that converges to L, then this limit can commute. We say commute. So the limit jump into the function. Okay, commute with f. Remember we said that link operator, link function, this link notation is an operator. Okay, so this two function commute. Does it make sense? Okay, this two function commute. Okay, so under what condition? Only when the f is continuous at L, you can do this. Okay, any picture in your mind? Do you have picture in your mind or not? Do you have picture in your mind? Huh? Isaac, how would you draw the picture? You don't know how to say it. Have you drawn it up? Not yet. Okay. So give yourself a sequence first, AN. Okay, give yourself a sequence AN. Okay, then maybe converge to some number L. Okay, and then what can you do? You apply f on this sequence here. Okay, you apply a continuous function on this sequence here. So this green dot here will be your f a n, and then the bottom here is your a n. Okay, and then what it converges to this point here. So bottom here converges to L, and then the top here should be f L. So this line here is f L. So this is what the theorem says. Okay. Yeah. Okay. So we won't prove this. Okay, we won't prove this. This is we'll prove this in MA1. Okay, if you want to do it, you can do it in your project. So we will use this again. Anyway, we will use this. We will use this. So let's use in this example here. So how about I give you 1 minute to work out this yourself first. Try first. See if you can use this theorem or not. Okay, try on lim. Sorry, lim, not lim. Sin sine pi over n. Okay, sine. So you need to how to say, analyze which one is functional, which one is continuous function, and then which one is the sequence that you need to apply. I'll give you 1 minute. Very short question. Okay. I know what's your answer first before we see how to prove it. Do you have an answer? Any try? 0. Does anyone else get 0 also? Anyone else get 0? Okay. 0. Okay, good. So how do we do this? What's the AN we are looking for here? Right? Not quite. Not quite. I mean the AN in this question. So we need to find AN and F. So what's the AN we're looking for in this question? How about N? Okay. And then what's the F we are looking for? Where's the F? Sine X. Real. Okay. So that we are looking at FAN. So FAN is what this question asking. Okay. So since what? Since we know that AN, which is pi over N, converge to 0, okay, when N go to infinity, and we also know that sine is continuous where? At the limit point, which is 0. So by theorem above, what can we do? Limit sine pi over n, we can commute. We can bring the limit into the function so that we evaluate sine at 0, which is 0. Okay. Make sense? Okay. 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 Any question? Any question? So if you want to use this method to find limit, make sure you need to identify what the sequence you need to use, what is the continuous function you have. Things. Okay. Okay, good. I think we only have 5 minutes left. So maybe we'll introduce some definition and idea, and then we will finish. Yeah. Okay. Is everyone okay with this example already? Yeah. Okay. So let's introduce some definition and then talk about one theorem, and then discuss about idea. Then we can break. So, so there are few adjective for a sequence. Some special sequence, special kinds of sequence we can look at. So a sequence could be what we call increasing. Okay, increasing means what? The next term should be strictly greater than the previous term. And non-decreasing, okay, non-decreasing means what? 没有减少，没有减少。So meaning what? You can either increase or stay the same. Okay, we allow less than or equal sign. So similarly, we can define for decreasing, and also we can define for non-increasing. Okay, so you need to be aware of these terminology. So if it decreasing means what? It is strictly decreasing. Okay, strictly greater. And if it's non-decreasing, meaning it is weakly decreasing. So there are other terms to describe. But most importantly is on this inequality you use. Are you using a strict inequality or you are using just an inequality? That's the main. So a sequence is called strictly monotone. Okay, so here we put strictly. So do you want to guess what are strictly monotone? If an is increasing or decreasing. Okay? If you use the strict inequality, we call it strictly monotone. And if it is non, 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 if it is non-decreasing or non-increasing, we just call it a monotonic. Monotonic. Mono. Non-decreasing or non. So let me ask you a question. Is strictly monotone sequence a monotone sequence or not? Is strictly monotone sequence a monotone sequence? Yes. Why? Sorry? Why? Is strictly monotone sequence. Why? Okay. You finished? Have you finished? You finished first. You finished first. You finished first. You finished first. Did everyone hear what she said? Non-decreasing include increasing. Non-increasing include decreasing. But in mathematical way, how do we phrase this? We will say that increasing imply what? Imply non-decreasing. Correct or not? Because this is less than or equal to. Okay, you can be true for either one of them. Okay, and also decreasing implies non-increasing. Okay, 2 more minutes. Right, good. And next idea is about bounded above. Okay, so a sequence is bounded above. What is it to be bounded above? Mean you have some bound above you. Okay, what's your bound? Jinsen, what's your bound? How far are you? What's your bound? 168. You can tell me 200 also actually. Right. 168 also bounded by 200. Okay. So what is bounded above? A sequence is bounded above if there exists an M such that this M is greater or equal to AN for all N. Okay, there's one number that is greater or equal to every number inside a sequence. Okay. And then similarly, you can define bounded below. Okay. So what is it to be bounded below? If there exists also some number n such that an is greater or equal to n for all terms. Okay, bounded below or bounded above. Okay, so we'll say that a sequence is bounded, okay, just bounded if it is bounded above and below. Okay, both, not just above or just below. Need to be both. It will be bounded. Otherwise, you will left another way to get negative infinity, for example, or infinity. Okay, so need to be both bounded above and below. Only we say bounded. Correct or not? You are also bounded above and below, right? Otherwise, you are not finite length. Correct or not? Okay. So one theorem I want you to go back and think about or remember is called this monotone convergence theorem. So since we have introduced all these terminology, right? So you should expect how we put them together. So how to put them together? So every bounded monotone sequence is the bounded monotone sequence convergence. So if your sequence is bounded above and below, okay, and then your sequence. So let's quickly get one diagram inside your mind. So if you have a sequence, okay, and then it is bounded above and below, and it is monotone, either non-increasing, either non-decreasing, it must converge. So from here, you will if it keep increasing, you will always hit a wall, right? The bounded above wall. Or you keep decreasing, you will hit a wall below, Okay. Does it necessarily meet the bound or not? Think about it. If it's or not. Okay, then we will try and discuss this again next time. Okay, see you on Friday.